Welcome to another video. Let's solve this system of equations together. It's a system of equations that involves radicals and non-radicals. So we don't even know if y times z will be a perfect square so that our answer coming out is going to be an integer. We don't know if we're going to end up with radicals. It was difficult for me to guess the answer, and I knew that the numbers were most probably different because all the answers on the right-hand side were different. But there was something that was very similar. Look, if you subtract 6 from 42, you're going to get 36. If you subtract negative 30 from 6, you're going to get 36. So in both cases, I got 36, and immediately I knew that subtracting one equation from the other is going to be a key. Then I tried adding all the equations together, and guess what? I got 18, which is half of 36 again. So immediately I knew adding and subtracting would be a path to follow. I tried it, but it did not give me the solution until my eyes got opened. Let's get into the video. So the eye-opening experience was when I stopped dealing with x. I stopped dealing with y. I stopped dealing with z. I started dealing with the square root of y and the square root of x and the square root of z. So that's how I'm going to start this solution. I'm going to replace the square roots with a different set of letters, and that's how we're going to proceed with what I just said. So let's say, let u be equal to the square root of x. So everything you're going to see in this picture will no longer be x, y, or z until the very end. We're just going to be dealing with u, v, and w, because from there we can build stuff from the ground. So I'm going to rewrite x as the square of u. So this first equation becomes u squared minus the square root of y times the square root of z, vw, minus vw equals 42. So from here, the manipulations I mentioned are going to come into effect. I am going to subtract this equation from this equation. So let me just label quickly. Let's call this 1, call this 2, call this 3. If I do equation 1 minus equation 2, what am I going to get? This minus this is going to give me u squared minus v squared. This minus this. Then this minus this is going to give me uw plus uw minus vw is going to be this minus this, which is going to be 36. Nice. Okay. Let's do this subtraction. I'm going to subtract this from this. I'm not going to subtract this from this because it doesn't give me a number that's going to be 36. So I'm going to just do these two. I'll subtract this from this. So again, if I do equation 3, equation 2 minus equation 3, I'm going to end up with nice. Nice. What I want to think of at this point is it possible for me to rewrite these expressions to factor this and factor this in a nice way so I can make something reasonable out of it? So let's still work here. Let's do some work here. Okay, let's call this equation tap, ta, da, tap, tap. We call this equation 4. We call this equation 5. Okay, let's block this out. If I rewrite this expression, there are two options, okay? I'm going to just use the one that worked. My first thought was, what if I give u squared minus vw to this guy? It didn't work out. So I decided to treat this as difference of two squares. okay? If you treat this as difference of two squares, notice that what's going to happen is you're going to have u minus v, u plus v, okay? So I'm going to have from equation 4, I'm going to have u minus v times u plus v, okay? Let's try to zoom into the side of the board. And if you look at this part of the board, you can take out w, and then you will end up with u minus v. So it's going to be plus w times u minus v, okay, equals 36. Okay, I hope you can see that. Now I'm going to just focus here, okay? Let's focus. Zoom. You will notice that u minus v is present in both expressions, both terms. So I can take out u minus v. I have u minus v here. And what's going to be left will be u plus v. And there's going to be plus w here. U plus v plus w equals 36. This is going to change everything. Because the same exact thing is going to happen here when I factor this. Similarly, from 5, I'm going to have from 5, I am also going to have v minus w. I have v minus w is going to give me u plus v plus w equals 36. Both are exactly 36. Do you see it? Ta 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 ta. So that clearly tells you that this and this are the same. So I can say that u minus v is equal to v minus w. Make this clean. Come on, clean up. Okay. Whenever you have something like this, it means there is a number that these two are equal to. Let's call that number d. Actually, whenever you have an expression like this, you say it's an arithmetic, they are terms of an arithmetic progression or an arithmetic sequence because they have a common difference. For example, if you have 5, 3, 1. 5 minus 2 equals 3 minus 1 is because this is a sequence. It's an arithmetic sequence with a common difference of 2. That's exactly what's going on here. So the three numbers we did this substitution with, u, v, and w, are in an arithmetic sequence. Twice the middle number is the sum of the two numbers that are adjacent. We just don't know what the common difference is yet, so we're going to call it d. Since we know that, we can write u in terms of d. We can also write v in terms of d. Well, it looks like there's going to be just one variable that becomes common. So look, from here, if you pay attention to these two, we know that v equals w plus d. And from this equation, we know that u equals v plus d. Therefore, we can write u in terms of w because we know that v is w plus d, just w plus 2d. That's what this is going to end up. U will be equal to w is going to be v plus d, which is w plus 2d. Nice. Better than rice. That's it. We have found a common representation for w, v, and for u. So let's go back. Pick one of the equations, any of the equations that we started with. I want to take the smallest number because this one is easier to deal with, well, in my opinion, and use this equation. So we can say from equation 2, we have v squared minus uw equals 6. V squared is going to be w plus d squared minus uw, u is w plus 2d, w plus 2d equals 6. Let's go. What do we have? Let's just distribute. If I expand this, I'm going to have w squared plus 2wd plus d squared. This is going to be, if I multiply this, it's going to be minus w squared. And this would be minus 2wd, minus 2wd equals 6. Nice. Better than spice. Notice that this guy, let's use another color of marker. This guy strikes this guy out. Woo. Oh, this one takes this one out. Now, when this happened, it blew my mind. Because we found the answer. Now, what's left is just d squared. It shows that d squared is equal to 6, which means that d must be equal to the square root of 6. Now, you might want to ask me, why are we not doing plus or minus? Well, obviously, looking at what we are working with, every single number has to be positive. I'm going to take care of that later because they're very obvious if you go back to the original question or the substitutions that we made. Okay, I'm going to explain that later, but let's do this. This is where the meat is. You just have to go back and find a very convenient equation to plug things into. Remember, we only know the common difference. We still don't know what u, v, and w are. So what I'm going to do is go back here because this one clearly tells me what this is d, because v minus w is what we call d, remember? So I can say v minus w multiplied by, all of these can be written in terms of d will give me an answer. So I'm going to say from, I didn't give this equation in number, so I'm going to give it the number 6. So let's call this equation 6, okay? So I'm going to say, from 6, I know that from 6, I can say v minus w. Let me write it out. I am going to write v minus w is the common difference, which is d. So, and d is square root of 6. Nice. Times, what is u? We said u is w plus 2d, w plus 2d plus, what did we say v was? V is w plus d, and w equals 36. Let's clean everything up. Here we have the square root of, you know what? Let's do everything together. So we have the square root of 6, So I'm going to plug in square root of 6 into every point I see d. So I'm going to have w plus, how many w's? I got 3 w's. Okay, let's just do that. So we have 3 w's plus 2d plus d. That's going to be 3 d's, but that will be 3 rad 6 plus 3 rad 6 equals 36. Now, if I distribute this, I'm going to end up with 3 rad 6w, or I can say 3w rad 6 plus, if I multiply this by this, I'm going to get 3 times 6, which is 18. Okay, plus 18 equals 36. Now I can subtract 18 from both sides. Rad 6 equals, if I subtract 18, I get 18. So that w is 18 over 3 times the square root of 6. Well, 3 divides 18, how many times? 6 times. So it's going to be 6 over rad 6, which is going to be rad 6. So w equals the square root of 6. We have solved the problem, because if w is square root of 6, we know that v is w plus d. So v equals w plus that square root of 6 plus square root of 6, which is 2 times square root of 6, which is equal to So that means v equals, now, can we write this as a radical? Yes. What is 2 times square root of 6? Is the square root of, push the 2 under the radical, it gives you 4. 4 times 6, 24. V is the square root of 24. And then u will be equal to v plus d. So it's going to be the square root of 24, square root of 24 plus the square root of 6. Yeah, maybe I don't want to use this strategy to find this because square root of 20, oh, I got it. 24 is 2 rad 6. So it's going to be 3 rad 6. That's it. So this is 2 rad 6. This 2 rad 6 plus rad 6 is going to be 3 rad 6, which is the same thing as the square root of, push the 3 under, you get 9. 9 times 6 is 54. So u equals the square root of 54. So from the work we've done, starting from the initial substitution, u is the square root of x. That means x must be 54. v is the square root of y, so y must be 24. And w is the square root of z, so z must be 6. 24 and 6. That is your solution set. Will we get other solutions? No. Why? Let's go back to the beginning, okay? So notice that if you look at the original question, if you move this here, you're going to have 42 plus this. That means x is a number greater than 42. Okay? X is greater than 42. That's why you can subtract something positive, because remember, the square root of any number is positive. Okay, so you're subtracting a positive number from x and you're getting 42, means x is greater than 42. The same thing, y is greater than 6. Okay? And if you move this over to this side, what you're going to have is you're going to have z is square root of xy minus 30. Z also must be positive because x and y are both positive. Okay, you don't believe that? Okay, think about it very well. You will notice that if x and y are both positive, then this must be a positive number, and it's impossible for z to be negative, because if z is negative, then one of these numbers will be imaginary. Z cannot be negative because x is positive. That's it. So these are the only solutions, and if you try them, you'll notice that 54, 24, and 6 are the only solutions. If you found another way of showing this answer, leave it in the comment. Never stop learning. Those who stop learning, stop living. Bye-bye.